I'd like to talk to you today about the scale of the scientific effort that goes into making the headlines you see in the paper. Headlines that look like this when they have to do with climate change, and headlines that look like this when they have to do with air quality or smog. They're both two branches of the same field of atmospheric science. Recently, the headlines looked like this when the Intergovernmental Panel on Climate Change, or IPCC, put out their report on the state of understanding of the atmospheric system. That report was written by 620 scientists from 40 countries. They wrote almost 1,000 pages on the topic. And all of those pages were reviewed by another 400 plus scientists and reviewers from 113 countries. It's a big community. It's such a big community, in fact, that our annual gathering is the largest scientific meeting in the world. Over 15,000 scientists go to San Francisco every year for that. And every one of those scientists is in a research group, and every research group studies a wide variety of topics. For us at Cambridge, it's as varied as the El Niño oscillation, which affects weather and climate, to the assimilation of satellite data, to emissions from crops that produce biofuels, which is what I happen to study. And in each one of these research areas, of which there are even more, there are PhD students like me, and we study incredibly narrow topics, things as narrow as a few processes or a few molecules. And one of the molecules I study is called isoprene, which is here. It's a small organic molecule, probably never heard of it. The weight of a paperclip is approximately equal to 900 zeta illion, 10 to the 21st, molecules of isoprene. But despite its very small weight, enough of it is emitted into the atmosphere every year to equal the weight of all the people on the planet. It's a huge amount of stuff. It's equal to the weight of methane, and because it's so much stuff, it's really important for the atmospheric system. Because it's important for the atmospheric system, we go to all lengths to study this thing. We blow it up and look at the pieces. This is the U4 smog chamber in Spain. Atmospheric explosions, or full combustion, takes about 15,000 times longer than what happens in your car. But still, we look at the pieces. We run enormous models on supercomputers. This is what I happen to do. Our models have hundreds of thousands of grid boxes calculating hundreds of variables each on minute timescales. And it takes weeks to perform our integrations, and we perform dozens of integrations in order to understand what's happening. We also fly all over the world looking for this thing. I recently joined a field campaign in Malaysia. There are others. We found a global atmospheric watchtower there in the middle of the rainforest and hung hundreds of thousands of dollars worth of scientific equipment off this tower to look for isoprene and, of course, other things while we were there. This is the tower in the middle of the rainforest from above, and this is the tower from below. And on part of that field campaign, we even brought an aircraft with us. And this plane, the model BA-146, which is run by FAM, normally flies 120 to 130 people. So maybe you took a similar aircraft to get here today. But we didn't just fly it. We were flying at 100 meters above the top of the canopy to measure this molecule. Incredibly dangerous stuff. We have to fly on a special incline in order to make the measurements. We hire military and test pilots to do the maneuvering. We have to get special flight clearance. And as you come around the banks in these valleys, the forces can get up to 2 Gs. And the scientists have to be completely harnessed in order to make measurements while they're on board. So as you can imagine, the inside of this aircraft doesn't look like any plane you would take on vacation. It's a flying laboratory that we took to make measurements in the region of this molecule. We do all of this to understand the chemistry of one molecule, and when one student like me has some sort of inclination or understanding about that molecule, they write one scientific paper on the subject. And out of that field campaign, we'll probably get a few dozen papers on a few dozen processes or molecules. And as a body of knowledge builds up, it will form one subsection or one subsection of an assessment like the IPCC, although we have others. And each one of the 11 chapters of the IPCC has 6 to 10 subsections, so you can imagine the scale of the effort. In each one of those assessments that we write, we always tag on a summary, and the summary is written for a non-scientific audience, and we hand that summary to journalists and policymakers in order to make headlines like these. Thank you very much.